Please move the slide, whoever is operating. And Axiom 4 mission is a very prestigious mission. We have successfully accomplished, and the first Indian is sent to safely to International Space Station and brought back safely. You are having the Gaganyaan 3 with us, Shubhanshu Shukla ji.
Group Captain Shukla emphasized the nation's readiness for venturing into human space flight. With this, India will join an elite club of nations that includes United States of America, Russia and China. Recounting his journey to the International Space Station, he said, the lessons gained from human space flight are invaluable. His experience at the ISS will be extremely helpful in India's Gaganyaan mission and the Bharatiya Antariksh Station.
The benefit of executing a human spaceflight mission end to end is more than the training actually. The supplementary knowledge that you get just by being there, the experience of it, the conversations that you have, the interaction that you have with people who have had a history of human spaceflight, it is invaluable. And I think all of this information that I have been able to collect in the past 1 year is going to be extremely useful for us for our own mission, the Gaganyaan and the Bharatiya Antariksh Station. And very soon we shall see somebody traveling up in our capsule from our rocket, from our soil.
Now let us get to understand more about mission Gaganyaan. India's space mission to independently send astronauts to space, that's number one. Aimed at developing India's human spaceflight capabilities. Third, a step towards making India a major space-enabled nation. Fourth, includes Made in India spacecraft and astronaut training program. Fifth, India will join select club of US, China and Russia. Strategic boost to India's space program. Now let me take you through some interesting details. Now Indian Space Research Organization is the agency. Objective, launch Indian astronauts into low Earth orbit. Budget, 10,000 crore. Technology, Made in India spacesuits, autonomous orbital maneuvers. Vehicle, GSLV Mk3 launch. Spacecraft, crew module with life support system for 7-day mission. Timeline, first crewed flight planned within a couple of years. Operations, astronaut training, crew module testing and flight simulation. The maiden test mission for Gaganyaan set for December marks a milestone in India's journey towards establishing a national space station. This will lead to a series of ambitious missions including a lunar landing by 2040 that will inspire future generations and reinforce India's place among the world's leading spacefaring nations. Through Gaganyaan, the country aims to join the exclusive group of nations, Russia, United States, China, that have independently sent humans to space.
10 years back, we had only one startup company in the space area in the country. Now today, under the leadership of Honorable Prime Minister and Minister of State, we are having 300 plus startup companies in the space area. That shows the significant growth of the startup system. And there are 2 suborbital missions done by private companies. And a week back, on August 8, a 30-ton solid motor is successfully tested for a private company, Vikram 1 motor, and for jointly done by ISRO and the private sector.
Now let me introduce my guests. Manish Purohit, former scientist ISRO. Dr. Selvamurthy, President, Emirates Science, Technology and Innovation Foundation, former DG DRDO. And Group Captain retired Bhinja, Senior Scientist, Aerospace and former Joint Director DRDO. Let me straight away go to Selvamurthy. Sir, how important mission Gaganyaan is for India? Please decode it for our viewers.
Thank you for having me at this discussion. And it's a very important milestone in the Indian space research, and then also towards the Gaganyaan mission, which is slated for the first quarter of 2027. So this, the exercise which we are doing, G1, Gaganyaan 1, which was just announced by the chairman ISRO, Dr. Narayanan, that this is going to be very important in terms of seeing all the mission operations simulated in complete functional the simulation. That is, the first thing will be the crew module in terms of its habitability, in terms of its configuration, its operations. Everything will be tested first. Then the life support technologies like the temperature and the oxygen, carbon dioxide removal, and also the all other life support factors which are required will be tested. Then the communication from the spacecraft to the ground station, telemetry and voice communication. So everything will be like as if an astronaut or a Gaganyaan 3 sitting from inside the spacecraft will be operating. So there will be communication. And then the third one will be, they will be doing experiments. So this the simulated Vyom Yatra, Vyom Mitra, will be having the actual, the experiments being conducted, like doing an experiment on agriculture or doing a materials research. So all this will happen in this. So this is a very important, and we will also be testing the crew escape system, which is very vital if there is an accident, because the foremost importance is safety of the Gaganyatris who will be going in this Gaganyaan mission. So it's very important. That is why we are doing this simulation. And then we will also be looking at our own indigenous technologies, like for example, parachutes, which are coming from DRDO, the ADRD Agra, the DRDO which I served for 40 years. So we are giving a lot of support to this ISRO activity today. The parachutes, 10 parachutes which are essential, the pilot and also drogue as well as the main one will be reaching, and they will be tested. It has been tested, but in the real situation, it will be tested with the crew escape system. And we will also be testing the life support system which is being indigenously developed, the space suit. All this will be put into this. The actual Vyom Mitra will be doing simulation of the Gaganyaan 3 sitting inside the crew compartment and operating it.
Okay.
So they will be doing the manipulations of the switches, their display monitoring, and also giving voice command in terms of Hindi
Okay.
as well as in English. So all this will be simulated. So this is a very, very important step towards the manned space mission, which is slated for the first quarter of 2027.
Okay. Manish, quickly to you, a lot of people have seen the International Space Station. I know it's a very limited technology. What is required to build a space station? How niche is that technology? Because sending a person to space is one thing. Creating a space station is another thing. And a lot of people, when they see that space station, obviously the desire is India should also have one.
Yeah, thank you first of all for bringing me on this panel. And actually right now what is happening is, if you look at Gaganyaan, it's a precursor to our Bharatiya Antariksh Station. So Gaganyaan mission, the plan is we will first get hold of the technology that is required to keep our Gaganyatris safe in space, orbiting around the Earth, staying there, testing all the required technology, making safely back home, re-entering into the Earth's atmosphere and doing the splashdown in Indian waters. Gradually, once that technology builds up, then in 2028, we are going to launch our first BAS-1, the first module of the Bharatiya Antariksh Station. Then we will be going again with the Gaganyaan module, and it will be a cargo supply module. It will go and attach to the BAS-1 module post 2028 after the launch of BAS-1, and gradually one by one we will be setting up the whole BAS with all the 5 modules, and then there will be frequent flying of our Gaganyatris to the Bharatiya Antariksh Station. And post 2035 it is planned that there will be a continuous stay of minimum 6 months, just like we have on International Space Station right now. Since its inception, International Space Station for last 25 years has been occupied, has human occupation for every second of those past 25 years. Similarly, once our Bharatiya Antariksh Station becomes operational by 2035, we will have continuous rotation flights every 6 months of Bharatiya Gaganyatris from our own land, in our launch vehicle, in our crew module, going to Bharatiya Antariksh Station, doing amazing science, doing amazing research, serving the humanity.
Okay.
So if you talk to
Okay, Mr. Jha, but what is the technology challenge when we talk? It's a big leap. What is the technology challenge? Can you just break it down for our viewers? Mr. Jha, 5 big technology challenge when we talk about space station.
Look, Karthik, I wish ISRO the very best of it. I also wish that Group Captain Shukla, whatever expertise he has brought with him, will surely be very, very useful in the coming, months, years, and maybe decades. But I'm slightly critical of the way how the entire thing is progressing, because initially, when PM had announced the program way back in 2019, with a view of having it going by about 2 years, 2.5 years, or something like that, we were critical because we knew if the entire system is being imported or purchased off the shelf from any of the countries, maybe Russia, maybe France, maybe USA, then it's okay. Then they can go ahead with that. But if it is the Indian system, then there is a problem because Indian system, none of that. I have worked on the life support system for the only aircraft that we have had in India. I am part of it. So I know how difficult it is to design, develop, and certify the life support system, and especially in the space arena. When we are talking of the crew module, this crew module doesn't have only the life support system. It is an integrated, the entire environmental control and life support system, with every breath being monitored by the computerized system and in automation being worked out to keep the environment absolutely congenial to healthy living. That is something, it is easier to talk to me in one sentence, but it's a hell of a task. I have spent a hell lot of time onto that. I have written a book onto it. This is regarding the human space flight. It is only the concept. I have not worked on the actual system. It is only the concepts with which we can go to the space. And it's an immense system. And when ISRO says that they are developing their own, I'm slightly skeptical because till now they have not developed any system. This is the first time that they're going to have it. Secondly, I know initially in 2012, 2013, we had one small interaction with the ISRO. They showed their interest into our system, and thereafter they thought possibly they are going for one mission or two mission. They will do off the shelf buying and they will go ahead. But it doesn't happen that way. So I know their system, especially the breathing control system, has not gone through the normal evaluation or experimentation or test or trial. So I'm slightly reluctant to say anything on that. And last, I'm slightly skeptical of the ISRO's certification procedure. They had one CES test, and I was very, very critical of their procedure. They ejected the capsule at say about -7 G, wherein in flight, when the ejection is required, it is about 4 G. At 4 G, you have got 4 times the load of the entire capsule, which you have experimented at a much lower. So, this way, usually in a design and development, we have got a separate independent certification agency who are not influenced. That is, I think, somewhere it has to come into play.
Okay. Sir, would you like to respond to this, Mr. Silvamurthy? I think Mr. Jha views are on the
Group
other
Captain
side.
Jha he has been my colleague. We have worked together in DRDO. In fact, at Debel, he was the director. He was the senior scientist there when I was DG DRDO. So he is so meticulous, and particularly he's only cautioning that all the certification process, validation, since we are going to use 85% of indigenous systems, he cautions that, make all measures to see properly validated, certified for space application. That is the concern which he raised. Otherwise, now the science has moved very fast. ISRO and DRDO and the national capabilities have increased so much, and the confidence level of the ISRO scientists operating is phenomenal. And we are all there to guide them. And Group Captain Jha is there, and we are there from the DRDO. And we will give all our inputs because our country today is in a different frame. So we can do things much faster, more precisely, highly reliable. So all this reliability and also precision, accuracy, and also safety, everything now we have come a long way. So I'm sure we still have another 3-4 months. So
no, I completely, I understand it, Manish, because even if you look at the NASA program, even if you look at the Falcon X program, I mean, despite billions of dollars, they couldn't get the astronaut back for a year, They just couldn't get her back. Because she was stuck up there. I mean, unfortunately, some astronauts also died because of the re-entry issue. So it's not as if that the Americans have not undergone the challenges. I think they continue to face the challenges. That is why the entire industry has opened up and the private sector is there. So yes, Mr. Jha does have a point in terms of the challenges which are there. That cannot be brushed aside.
Yeah, space tech is really hard. It's a tough task. See, if you talk about ECLSS, that is the main, that's the most critical aspect of the whole human space flight program. So it has to sustain the environmental control and life support for the astronauts. If you talk about the Apollo program, initial years of the NASA research, there have been mishaps, there have been lives lost due to here and there are some technological misadvantages. But then right now, if we have to go for completely indigenized Gaganyaan program, we have to go ahead with the ECLSS. Right now, the engineering level aspects are ready for the ECLSS as per the recent updates. And we have to go ahead with our own system because somewhere maybe 2-3 years back, we know that we were denied that environmental control and life support system was denied to us. So we can't go in part by part, some part from here, some part from there. Either it has to be a complete technology or it has to be our own technology. So bottlenecks are there, challenges are there, but then we don't have any other option. We can't simply wait and, sir is raising a very valid point that certification part has to be very strict, very stringent. The points he is making that make a very valid point when we are talking about quality assurance. So I think there will be few steps in place when we talk about ISRO certification and qualification processes. They have their in-house quality assurance teams which are very, very strict. I know them.
No, because the point in the space technology is, Manish, you can't afford a single mistake.
Yes.
No, it can't be probabilistic.
Yeah.
You can't have a probabilistic approach.
There is
it
no
has to be
single
very
mistake.
deterministic.
Yes. You can't have a single mistake.
Yeah.
But I think G1, G2, G3
We will keep redundancies for that.
Yeah.
Yes.
That's why we
Especially
have G1, G2, G3, yes sir. That's why we have that.
What were you saying, sir? Mr.
And
Selvamurthy?
this particular flight.
Yes, sir.
Yeah.
Mr. Selvamurthy, what were you saying?
In the human space
that
program,
is the reason we have before we put the
life of the
human in
person is
space.
at stake on the life support system, on the automated life support system. There you just can't take a chance. Even if there's a 0.1% of a failure, that you cannot do it. You strictly run a complete failure mode assessment, and even there is a 0.1% failure, you can't let that mission go into the space. We have seen what has happened with the Starliner, a Boeing spacecraft going to the International Space Station. So all these things are there. So one thumb rule we have given for the space launches, that if you have got slightest of the doubt, don't launch the spacecraft. Be absolutely critical when it is human, because if anything goes wrong, any of the system, look, with every breath, additional oxygen comes into the crew space. How much oxygen should come? That is deliberated by the entire automation system. How much I breathe, that carbon dioxide has to be filtered out of the system. How much I breathe, that water vapor, it has to be removed from there.
No. Mr. Jha, today I don't want to scare everyone. I really don't want to scare everyone by the space science. I just wanted to make my viewers excited about the fact that this is the audacity of hope. This is what we are trying to achieve as Bharatiya. So, but it's good to have all of you. I've really run short of time, Manish. Maybe next time we'll have a broader conversation on this. But today I will end my on point with one and the most important bite of Shubhanshu Shukla. I'll see you at the same time tomorrow. Good night, but you listen to him.
The key message that I've had throughout the mission, while going up, while on orbit and while coming back, भारत आज भी अंतरिक्ष से सारे जहां से अच्छा दिखता है. जय हिंद, जय भारत.
Associate sponsor Dyna Premium Beauty Soap. पहली झलक करे खूबसूरत.
Go condoms?
It's over there.
क्या ये different sizes में आता है?
Actually sir, size matter नहीं करता.
तो फिर क्या matter करता है?
The hardness
Of the condom.
of what's inside.
For the first time ever, presenting Hard Rock Gel.
अब free हर score condoms के 10 पैक के साथ.
एक मिनट क्या हुआ? अभी से इतना खर्चा करोगे तो मेरी पढ़ाई का क्या करोगे? तुमने पहले ही लाइफ इंश्योरेंस का चाइल्ड प्लान सोच रखा है इसके लिए।
सपनों को रखो सुरक्षित चाइल्ड प्लान के साथ। सबसे पहले लाइफ इंश्योरेंस।
ये बेस्ट है सर।
हमेशा वाला क्यों नहीं?
सर हमेशा
मिश्रा जी, आपके लिए फूलों की बरसात।